We will now begin section 3.5 and discuss transformations of functions. We'll start by learning about a horizontal shift. Let f of x be a function and let h be a fixed real number. If we replace x with x minus h, we obtain a new function. G of x is equal to f of x minus h. The graph of G has the same shape as the graph of f, but shifted to the right by h units if h is greater than 0, and shifted to the left by h units if h is less than 0. Essentially, what this is telling us is that if we take a function, say we take the square function, and we replace the x with x minus h. So if I erase the x, and in its place I put x minus h. Now this entire quantity would be raised to the second power, so I am going to put it in a set of parentheses. Then the graph is going to shift to the right h units, and likewise, if we had taken our original function x squared and we erase the x, and in its place we put x plus h, then that would cause the graph to shift to the left h units. Now, the thing that tends to be a little bit confusing for students is the direction of the shift. And so what you want to think about is that it actually does the opposite of what you're looking at. So if you have a minus h here, it's going to shift to the right, which is a little bit opposite. We would think if it was a negative, it would maybe shift back to the left, but it does not do as expected. And here we have a plus h, which is going to cause it to shift to the left. So let's look at a couple of examples. Sketch the graphs of the following functions. Part A asks us to sketch the graph of f of x is equal to the quantity x plus 2 raised to the third power. So what we need to do first is we need to correlate this back to one of our basic functions. So this is the cube function. And we know that the cube function has a graph that looks like that. So now we need to look at the problem that we're given and ask ourselves how that is changing. So if I take my original function, which is x to the third, and I replace the x with this x plus 2, now I have an expression that is the same as what we were asked in the problem. So what kind of shift has occurred? If I've added 2 inside the function, that is going to cause it to shift to the left 2 units. And so when we go to draw our graph, instead of it crossing at the origin, the graph is going to move back and it's going to come in and cross right there at, no, not there, hold on. It's going to cross at -2. And then go up. And so the entire graph is going to have shifted 2 units to the left. All right, so let's look at part B. Part B says that we have g of x is equal to the absolute value of x minus 4. So g of x is equal to the absolute value of x minus 4. Now again, we want to correlate this first to one of our basic functions. And so this is our absolute value function. And we know that the graph of our absolute value function makes a V with the vertex at the origin. So now let's think about this original function and how it has changed. So it started out as the absolute value of x, and it has now become x minus 4. So in other words, what has happened is they have taken that x and they have erased it, and in place of that x, they have put an x minus 4. So what effect does that have on the graph? So the -4 is going to cause the graph to shift to the right 4 units. So instead of the graph coming down and touching at 0, 0, it's now going to come down and touch at 4 on the x-axis. And so our graph will look something like that. We'll also look at vertical shifting. So vertical shifting says let f of x be a function whose graph is known, and let k be a real number. And so the graph of the function g of x is equal to f of x plus k is the same shape as the graph of f, but it's shifted upward if k is greater than 0, and downward if k is less than 0. So again, this is saying that if you take a base function, like your square function, and then you add a number to the end of it, so not a replacement like we saw in the horizontal shift, but simply tacking onto the end of the function maybe a +2, then this is going to cause the graph to move up 2 units. And likewise, if you take your original function x squared and you subtract a number off of the end of that function, this is going to cause your graph to move down that number of units, so down 3. So again, let's look at a couple of examples of this. All right, so sketch the graph of the following functions, and part A asks us to graph the function for 1 over x and then +3. So again, we have to know what our base function is. So our base function is 1 over x. And we also need to know what that base graph looks like. So if I were to graph 1 over x, that graph looks like this. And so now we look at what happens if we add 3 to the end of that function. This is going to cause the graph to move up 3 units. And so you're basically going to need to take each piece of this graph and move it up 3 units. And so our graph is going to look maybe something like this for this piece, having moved it up 3. And then maybe something like this for that piece. All right, our part B asks us to find g of x is equal to the cubed root of x minus 2. So the cubed root of x minus 2. So again, we need to start by saying, okay, this is our base function, the cubed root of x. And what does that graph look like for the cubed root of x? And so we know, or we can use our calculator if we don't know, that that graph is going to look something like this. And so now what's going to happen if we have as our graph g of x is equal to the cubed root, and we subtract 2. So what is that minus 2 going to do? It's going to move the graph down 2 units. All right, so instead of that graph crossing at the origin, it's now going to cross right about there. All right, so we can come down and we can kind of sketch out that graph and have it be something like that. Okay, so the next thing that we want to look at is we want to notice that we have one other option that can happen on our graphs, and that option is that we can throw in some negatives and look at the effect that those negatives have on the graph. And so there are two things that can actually happen here. One of those is that you can put a negative in front of your function. So in other words, and I'm just going to make a little note here, in other words, you can change your function to a negative function. So that's the first option that we have, is putting a negative in front of the function. And when we do that, what effect that has is it reflects it over the x-axis. The other option that we have is we can actually do a replacement, and we can replace the x with a negative x. And if we do it that way, it's going to reflect it over the y-axis. So with that in mind, let's look at these two examples that we have here. Part A asks us to graph f of x is equal to negative x squared. So again, you need to think about what your basic graph is and what it looks like. And so this one is going to be based on the graph of x squared, which we know is a parabola with vertex at 0, 0. So what has happened here? It appears that we have taken a negative and placed it in front of the function. And so we know that if that has happened, if we've placed a negative in front of the function, then we should be seeing a reflection over the x-axis. So keep in mind, this is your x-axis. And so our new graph is going to be that same parabola, but it's going to be flipped down. All right, so let's look at part B. Part B, we have g of x is equal to the square root of negative x. And again, think about your basic functions. This one is going to be your function, the square root of x, and that graph is going to look like that. And so what has happened here to go from our original function to the new one? It appears that at some point they erased the x, And in place of that, they put a negative x. So this should be a reflection over the y-axis. And so let's draw that graph. And we're going to reflect it over the y-axis, so it's going to come back in this direction. So in this first section of this section, you want to consider the vertical shifts, the horizontal shifts, and then reflecting by putting a negative into your function.